We are back with another set of videos, this time for class 16 in thermodynamics. We're going to talk about the transient flow process. I'm not going to put as much emphasis on this. I think there's only 2 homework problems that are related to it, and this will end our work in chapter 4 of Bergnacki. Let's see what we have on the next page here. All right, so if we had this thing not shown, which is for the Yeti microphone. I swear I got rid of it. I don't know how it came back, but it did. If you would see, this would be section 4.6. And so we're going to deal with, well, we've been dealing with steady state conditions. Here we're going to have a condition where we have some unsteadiness, I guess you'd say. So things are going to change with time, but not a whole lot. We're just going to have really just 2 instances. So this is really sort of a simplified scenario. There could be all kinds of crazy things in terms of, like, transients and random things taking place, chaotic events. We're just going to deal with the state where things change, or I think that's not it's not a really descriptive way to put this. Let's just take a look at the thing, and then you'll understand what I mean. So something's going to change with time. So we're going to make some simplifying assumptions for the mathematical analysis. First, we're going to say that the control volume remains constant. All right, so we're not going to be like moving the control volume around. The thing is going to be uniform throughout the control volume, right? And lastly, and then this is a mistake I need to correct in the notes. I'm tired. It's late. This should be the state of the mass. All right. So the state of the mass crossing the control surface is constant with time. So the mass might not be constant with time. In fact, that's really the thing that we're going to be doing. Really, the only type of really transient thing we're going to be doing is that the amount of mass inside the control volume changes with time. So the continuity equation, therefore, is going to become the change in the mass in the control volume with time is going to be equal to the difference between 2 states, state 2 and state 1. And so that's going to be the difference with time. So we will now just go ahead and say, well, we have, that's going to be, so the amount of mass inside the control volume is going to be equal to, or the difference of the mass in the control volume is going to be equal to the sum of the masses coming in and the minus the masses coming out, right? So this is the continuity equation for the transient. In a similar way, the energy equation, I just bit my tongue a second ago. We're going to talk about the energy that within the control volume. And so we can call these E2 minus E1, and we could say, well, this is going to be related back to the mass that's changing in the control volume. So that's mass 2 times the specific energy 2 minus mass 1 times the specific energy mass 1. So the way that this works out here is this stuff on here on the left-hand side is what we're talking up here. And quite often we are going to go ahead and use little u's. I should point to this. So we're going to have internal energy is what we're going to be measuring the change there. So the mass times the internal energy. And you notice it goes 2 with 2 and 1 with 1. All right, so those are important things to check out. And then the stuff on the right hand is the same things that we've been doing, right? So we got the heat change in the control volume, the heat change, the work change across the control volume. And then we have the mass entering, which mass in I guess is their I, with all these properties in, and then minus the mass exiting and all of these properties of that mass exiting, right? So really the biggest difference is that we're going to have some types of changing thing going over here. So it's not conservation of energy. Well, it is conservation of energy, but it's not the conservation of energy for a steady flow because the mass is not remaining constant. And therefore the mass in the control volume is not remaining constant. And therefore the energy within the control volume is not. Boy, that took a long distance to get around. And what was that, like 5 minutes? That's probably right there with one of the worst videos I've ever made. I can do better than this. But that's long enough that I'm going to make it a standalone video, and I'm just too tired to make new videos. So if this is the first video you ever saw of me, yeah, I could do better. I have better videos than this, but I'm tired, and I got to record these before I'm teaching the class tomorrow. So gotta move on. Don't judge me.